Welcome back. For this class, we will talk about the variable. The content of this class will be the following. 1. Use of numerical variables. 2nd, use of array variables. 3rd, use of string variables. 4th, use of speed variables. And at last, use of positional variables. The lecture time will be around 10 minutes and the objectives are following. Understand the different types of variable, understand the role of variables, and understand the user scenario of read-write methods of various variables. The concept of variable comes from mathematics, which is an abstract concept in computer language that can store calculation results or represents values. Variables can be accessed by variable names. In an instruction language, variables are usually mutable. Click Add Variables on the programming interface to add the following types of variables: system variable, number type, program variable, number array, string type, speed variable, and position variable. The system variable is the global variable, which can be used in different programs. After the program stops, the number of system variable will not be restored to the initial value. The program variables are, on the contrary, local variables, can only be used in a current program. The program variable will be restored to its original value after it stops. If you need to delete the added variable, you can click on the minus sign and the delete button will be displayed after the variable. Click the delete button to delete the existing variable. In addition, system variables can be added in our setting interface program settings. Currently, only numerical system variables are supported. Let's look at an example with a variable number. For this program, we will make a 3x3 palette counting variable, increase 1 each time. The start of this program specifies the initial feeding position, which can also be given by external device. If we use the system variables, we can change them directly into the settings. We set a variable number called num, and we input inside the value 3. Then we have a repeat loop for the whole operation and a function of a palette. Inside this palette, we will have two linear motion, down and up, like to pick up a part. The initial position will be the position inside the variable. Here on the example will be 3. After making the up-down movement on the palette, the robot will set the numerical value to be +1. Variable equal variable +1. Then the instruction here will be ignore, because it's not greater than 9. Then the robot will make a loop and pick up the parts as long as we need to reach 9. When the numerical variable num is greater than 9, it will reset the variable to 1. And then it will start again the movement. Now let's have a look at a variable array example. The program uses array variable to hold Cartesian coordinate at the end of the robot. After, it uses numerical variables to hold a specific element of array. For this example, we'll consider an array in the program variable family, hold 6 subscript. Each subscript corresponds to a position of the robot with a Cartesian coordinate. Subscript 0 corresponds to x, subscript 1 corresponds to y, subscript 3 corresponds to z, and the 3 last correspond to the rotation around x, y, and z axis. Now we will look on the program on the right. First, we start to create 3 variables. One array called current position, and 2 numerical values called x and y. The first line of the program, we ask the robot to input inside our array called current position the localization of the end tool center location. Then the robot will input inside X and Y using subscript 0 and 1 the current position of X and Y. After, we will see three conditions. If X is greater than 0 and Y greater than 100, the robot will move to the A position. If the X is greater than 0 and the Y less than 0, the robot will move to the B position. Both are using a joint motion. The last condition is X is less than 0 and Y greater than 200. Then the elements inside the array for the Z value will be set at 200. Then the robot will move to the modified value. It is possible to input inside the linear motion the localization inside the array. It's like a coordinate for a point. Then it will be the same for the Y value and X value. This condition allows the robots to move each position by each position. After the program is finished, the robot will return to the initial position. Now we are going to talk about the function access subscript. The access subscript function is a way to read the information inside the array. For example, in this program, we use the open socket program to ask the robot to read inside the subscript number 3 and send us what's inside. For example, the name of this array is 2 with these current values inside. All the values are separated by a comma. By using the program of accessing the subscript number 3, we see that the final result will be 85. Because indeed, subscript 0, 1, 2, 3 is 85. For information, the subscript 0 here corresponds to 256, and the last subscript number 5 corresponds to the 96. Remember that we always start the subscript with 0 and finish with 5. For the next function, it will allow us also to read inside the array. The only difference is we can choose where to start and where to end. For the following program, we wrote a communication protocol and asked the robots to send us what's inside the array. We want to cover all the elements inside the array, so we choose the start at 0 and the end at 5. The step value of 2 will ask the robot to read every 2 numbers inside the array. With such program, we can see that the result will be 256, 10, and 0. If you watch the result, it is correct. If you want the robot to give us every element inside the array, we should choose a step value of 1. The next function will be set array elements. With this command, we can modify the element inside the array. In an example here, we want to change the subscript number 3 and replace it with the value 888. If you remember the element inside the array, the subscript number 3 will be 10. After running the program, we can see that the element inside the array, subscript number 3, have been replaced with 888. The string. The variable string allows us to put not only numbers but words inside the variable. When you use a communication software, if you want to put even numbers into a variable, you need to use a string. If you want to convert these numbers into a position, we need to use this function to convert the string into array. Let's have an example. Here, we start to set an initial position for the robot. Then, We establish the communication sockets and wait for 1 second. After, we ask the robot to put inside the string what we write in the communication software. Then we establish a string with no value inside. The same for the array. We don't need to put initial values inside. Then, after the robot moved, we ask him to send us OK in the communication software. Here we notify the robot that we will separate our position by a comma. After, we set the IP address of the robot and connect. We can run the program. When the program is launched, we just need to send the robot the new coordinate. Here will be the Z position. So the robot will simply move along the Z axis. We see the behavior of the robot. He moves and then sends OK. We don't need to relaunch the program every time. The program is optimized to be used without touching it. The variable velocity can cover the speed set in the motion instruction and run accordingly to the global speed setting. The global velocity will overwrite the speed previously entered in the joint motion. Close the global speed command will cancel the motion speed override function. The next motion command according to the speed set in the motion command operation. For the example on the right, here, the joint motion 1 and 2 will be executed with the global velocity named speed. The speed entered in the joint motion 1 and 2 previously doesn't matter. After, the joint motion 3 and 4 will be executed with speed 2. After closing the global velocity, the speed entered previously into joint motion 5 and 6 will be executed normally. Variable position. The variable position supports manual input of joint or Cartesian coordinates. Click Edit to teach robot coordinates to automatically obtain the current coordinates. Then you can rename your variable, click on every coordinates to manually input yourself. You can also choose user coordinate and tool coordinate system. When you're done, you can click Determine and the robot will remember the position. In a program, you can just select your joint or linear motion and then slip the variable inside the position. When you execute the program, the robot will move to the position inside the variable. Variable position is useful for frequently using points. For example, pick and place or palletizing. This is it for the variables. Thank you for watching.